Hey brothers, how you guys doing? This is Coach Scott with my brand new YouTube channel, hashtag Purple Wave Chemistry. What do you guys think? So anyway, we're going to start, I'm going to make a nice little video to help you guys review for the Unit 5 exam, and hopefully this will help. Now, if you look to the right, I've got one of the problems from the review sheet. You can also practice on worksheet 3. There's several problems there. So one of the most important things we need to do is finding an empirical formula. What do we need to do first? Well, number one, if you have grams, let's just say get to moles, the number of atoms that are there, right? Because you want everything to be the same. So get to moles. After you get to moles, you're going to find the element with the least number of moles, and then you're going to divide each one of those by that. You're going to get a relative number of moles. Divide by the least, and that should give you some whole numbers. All right, number of moles. And if it doesn't, and we've got some examples in here, we're going to use some tricks, if you would, to get to the correct number of moles. Because an empirical formula is a formula from data, okay, that has the least whole number ratio of the atoms in the compound. Should get to whole numbers. Looking for is the formula with the least. That's a little way that we used in the military medicine to say with. Formula with least least whole number atoms or moles. Essentially, it's the same thing. Okay, so let's give it a shot. So what is the empirical formula of a carbon-oxygen compound? That a 95.2 gram sample of the compound contains 40.8 grams of carbon and the rest of oxygen. So this is just slightly tricky, but not too bad. So the total, and this is carbon and oxygen, and the total, all right, the total has 95.2 grams. 95.2 grams. So it gave us the mass of carbon. So carbon has, let's see, let me grab another pen. Carbon has 40.8 grams. Okay, so the rest is oxygen. So to get the number of oxygen, let's go to another pen. We'll use green. I'm going to use my calculator, and I'm going to put the total, 95.2, and subtract the amount of carbon, 40.8. Gives me 54.4 grams of oxygen. Okay, so now I've got my amount of carbon. Now we'll use black. Everybody likes to use black for carbon. So I've got 40.08 grams of carbon, and we'll use blue for oxygen. That's always a good one. So we've got, or we'll use red. Red's always good. All right, and for oxygen, we've got 54.4 grams. So I've got to get to the number of moles of carbon in this compound. So, okay, I'm going to divide through or multiply by 1 mole. Okay, and I'm going to look at my periodic table, and this periodic table has oxygen, has 15.99 grams per mole. So that means for every 1 mole, I've got 59.9 grams of oxygen. Oh, I messed up. I'm looking at carbon because it's black, 12.001 grams. 12.011 grams. So that means for every 1 mole of carbon, I've got 12.001 grams of carbon. All right, so let's do that real quick. 40.08, 40.8 rather, divided by 12.011. And I'm going to suggest to you guys, use whatever number your periodic table gives you. All right, whatever it gives you. So my calculator says 3.3968. So we're going to say 3.4. 3.4 moles of carbon. 40 moles carbon. So let's do the same thing, and let's use the right one. Come on, Coach Scott. So 1 mole has 15.999 grams of oxygen. Okay. It's equal signs there. So I'm going to divide the mass of oxygen by 15.999, and I get 3.4 moles. So this is going to be pretty simple. All right, so the least number of carbon, moles between the carbon and oxygen, well, is 3.4. So I'm going to divide through by that. That gives me a 1-to-1 ratio. Divide through by the least number. They're both the same. So that tells me that my empirical formula for this compound is CO, or carbon monoxide. Okay, so that problem is done. That's pretty simple. Okay. Have like a 2-to-1 ratio of carbon to oxygen or anything like that. Let's look at this one. Maybe we'll get lucky here. I doubt it. Okay, so what do we got? We've got a compound is analyzed. It is found to contain 9.8 grams of nitrogen, 9.8 grams, and 0.70 grams of hydrogen. Let's use red for that, or we'll use blue for hydrogen. Blue for hydrogen. Okay, and it says 0.70 grams of hydrogen. And then it's got 33.6 grams of oxygen. Oxygen. So looking through here, let's talk about sig figs. I'm looking at 2 sig figs as the least one. That's got 3. There's 2 there. There's 2 there. So we shouldn't have to report with sig figs with this because we're just going to get what we get. Let's see what we get. So first thing, we're back to we got to get the number of moles. Okay. And how do we do that? So I'm going to divide nitrogen, or multiply it by the ratio for 1 mole. Look at my periodic table. Okay. Table says 14.007 grams. So 1 mole of nitrogen has 14.007 grams. I'm dividing because I want to cancel out that number of grams, and that gives me the right number there, right? Okay, and that'll give me my number of moles. Let's go ahead and do that real quick. 9.8, 14.007. 14.007. Let's see what we get. Oh, I screwed up. Clear. 9.8 divided by 14.007. Let's see, I got .7. 0.70 moles of nitrogen. Okay, let's look at hydrogen. Look at my periodic table. My periodic table says hydrogen is 1.008. So I'm going to multiply by the ratio. 1 mole of hydrogen has a mass of 1.008 grams. 8 grams. Let's go ahead and do that real quick. 0.7 divided by 1.008. And I got 0.7. 0.69444. 0.7. We can round a little. Hydrogen. Okay, let's do oxygen. So oxygen, again, my periodic table says it has a mass of 15.9999. 3 nines. Okay. 1 mole oxygen has a mass of 15.999 grams. Let's see what that is. So 33.6 divided by 15.9999. I got 2.10 moles of oxygen. So again, I'm trying to get the least whole number ratio. All right, so I need to make, those are about the same, but I need to divide by the smallest number of moles, which in this case is going to be the same, 0.700. Okay, and that'll give me a number of 1. So I've got 1 nitrogen. I'll do the same thing with the hydrogen, 0.700. So that gives me hydrogen of 1. Then I do 2.10 divided by 0.700. And that's going to give me, let me do my little calculator so I'll make sure. 2.100 or 2.10 divided by 0.7, well, that should give me 3, and it does. So, to get my empirical formula now, I've got 3 good whole numbers. I've got N, and if I don't put anything down there, that means it's understood to be 1. That means I've got H, 1, and I've got 3 oxygens, NOH3. Be my empirical formula. It's the least whole number ratio. So hopefully this helps you guys out a little bit. Again, if you have any questions, see me before your test on either Tuesday, Wednesday, or Friday, and I'll be glad to answer whatever questions I can. Other than that, this is Coach Scott saying, hullabaloo, connect.